Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. In our previous videos, we have seen the introduction to sequence and series chapter, and after that we have seen what is an AP and how to find the nth term of an AP. So before watching this video, it's important to go through the previous two videos. Fine. And in today's topic, if you see, we'll be finding what is the sum of n terms of an AP, arithmetic progression, sum of n terms. Okay. The subtopics that we are going to see today is how to derive the formula to find sum of n terms. Sn is equal to n by 2 into 2a plus n minus 1 into d. And the second subtopic is some important deductions on Sn. And the third topic is the problems based on sum of n terms. So these are the three things that we are going to see in today's video. So let us continue. First, let us derive the sum of n terms of an AP. Now let us consider an AP given by an equal to a1, a2, a3 and so on an. The first term, second term, third term and so on nth term. Here sum of n terms means a1 plus a2 plus a3 and so on an. So let us derive a formula to find the sum of n terms. Let the first term is a, the number of terms is n, the common difference is d, and sum of n terms is Sn. Just remember this. Now let us continue deriving the formula for sum of n terms. Sn is equal to the first term a plus the second term a plus d plus the third term a plus 2d and so on, plus the last term is a plus n minus 1 into d. The last term is a plus n minus 1 into d. Now let me rewrite the same sum of n terms by reversing them. And in the previous video we have seen that the last term can also be taken as L. And the second term from the last is L minus d. The third term from the last is L minus 2d. Plus and so on. The nth term from the last is A itself. The nth term from the last. Let me add these two. Sn plus Sn is 2 times Sn. Now a plus L plus, when I am adding these two, plus d and minus d will get cancelled. Again I will get a plus L. And here plus 2d and minus 2d will get cancelled. We will get a plus L. And so on. And finally, one small change. The nth term from the last is L minus of n minus 1 into d. Now if I add these two, n minus 1 into d and minus of n minus 1 into d will get cancelled. Again I will get a plus L. The next question is, how many times a plus L is added? 1, 2, 3 and so on n. So a plus L is added with itself n number of times. So we can write it as, the RHS can be taken as n times a plus L. So therefore the sum of n terms formula is into 2 goes that side by 2. So n by 2 into a plus L, where L is the last term which is also called as nth term. So we know that L is equal to the nth term, that means a plus n minus 1 into d. And if I substitute the same in this formula, we get Sn is equal to n by 2 into a plus, the last term L is a plus n minus 1 into d. So therefore Sn is equal to n by 2 into a plus a is 2a, 2a plus n minus 1 into d. In some of the problems, when the first term, the number of terms and common difference is given, we will use this formula. And in some of the problems where the first term and last term are given, we will use this formula. So depending on the problem, we can use this formula or this formula. Now let us see an example based on sum of n terms. Here is a question. If the sum of n terms of the series 2, 5, 8, 11 and so on is 60,100, then the number of terms is, they have given a series, they have given a sequence, they have given a sum of n terms. We are supposed to find the number of terms, which means n. So what is given here? So it is very clear that the given sequence is in arithmetic progression, right? Given what is the AP here? 2, 5, 8, 11 and so on. Where the first term is 2 and the common difference is A2 minus A1. A2 minus A1 means second term minus first term. 5 minus 2, which is 3. The common difference is 3. And then the sum of n terms is 60,100. And what are we supposed to find in this question? The number of terms. We are supposed to find the n value. So let us take the formula itself that says Sn is equal to 2a plus n minus 1 into d multiplied with n by 2 at the starting. Sn is equal to n by 2 into 2a plus n minus 1 into d. So Sn we know that it is 60,100. N we are supposed to find. So 2a, 2 times 2 will get 4 plus n minus 1 into the common difference is 3. If we simplify this, we will get a quadratic equation in terms of n, and factorizing it, we will get the two different values of n. So let us continue solving this. If I cross multiply, I will get 0, 0, 2, 0, 12. So is equal to n into 3n minus 3 plus 4 will be 1. Okay. So therefore, if I expand this, 3n square plus n, and if this number goes to the right side, it becomes minus 120,200 equal to 0. So this is a quadratic equation in terms of n. We can find the values of n by splitting the middle term or by using quadratic formula. Our basics must be very strong in order to factorize a quadratic equation, particularly when the numbers are too big. If you are interested, you can use quadratic formula and you can find the result. But I always choose and I will try to split the middle term and to factorize it in order to find the values of n. So let us continue. Let me take a into c. If it is of the form a n square plus bn plus c. So this is a and this is c. I'll take these two. And if I multiply 3 into 120,200 with minus sign. This can be written as 1202 into 100 or 601 into 200 into 3. I'll pair these two. So 601 into 600. So the middle term is positive. So I'll take plus and I'll take minus. So the middle term can be split as 601n minus 600n. So 3n square plus 601n minus 600n minus 120200 equal to 0. Let me take n common into 3n plus 601, and here and here what we can take common? Minus 200. Minus 200 if I take common, again I'll get 3n. 203 is 600, right? And then since I took minus common, we'll get plus here 200 into 601, sir. Why I took 200 common means then only I'll get 3 here. If I take 200 common, I'll get 3 here. Here also 3 for that purpose. Now here and here we can take 3n plus 601 common into n minus 200. The factorization is completed. Now the product of two things equal to 0 means either the first one must be 0 or second one must be 0. If I take the first one to 0, I'll get 3n plus 601 equal to 0, and therefore n is equal to minus 601 divided by 3. But n, the number of terms, cannot be negative. So therefore we are not going to take this particular value. And then if I take n minus 200 to 0, we'll get n is equal to 200. Therefore, the number of terms is 200. Next, we'll continue with some important deductions. These are very, very important while solving the problems. The first result, the sum of first n natural numbers. What does it means? If I add the first n natural numbers, that is 1 plus 2 plus 3 and so on up to n, then what will be the result? An important result that will be used later while solving the problems. Now let us see. This series, it is clearly in AP 1, 2, 3 and so on. The common difference is equal to 1, right? So we can use the sum of n terms formula of an AP. So which formula I'll use? Look at this. Depending on what is given, I will choose the formula. Sn is equal to n by 2 into a plus l. I can also use 2a plus n minus 1 into d. It's not an issue, but here it is easier to get the answer in this method. So the number of terms n itself into the first term is 1 plus the last term is n. Therefore, what is it? 1 plus 2 plus 3 and so on up to n is equal to n into n plus 1 by 2. The formula to find the sum of first n natural numbers is n into n plus 1 by 2. So the same thing in short notation, it can also be written as sigma n, the summation of first n natural numbers. Remember this. A small example. What is the sum of first 100 natural numbers? 1 plus 2 plus 3 and so on up to 100. So where n value, the last number, n value is 100. So n into n plus 1 by 2. That means 100 into 100 plus 1 by 2. So 2 ones are 250s are. Multiplying these two, we will get 5050. The sum of first 100 natural numbers is 5050. The second deduction is the sum of first n even natural numbers, which means 2 plus 4 plus 6 and so on up to 2n. 2n is the last term, correct or not? If it is 2 ones are, 2 twos are, 2 threes are, then the nth term will be 2n's are, right? So if I add the first n even natural numbers, then what is the result? Very simple. Again, I'll use Sn formula as n by 2 into the first term plus last term. Here the number of terms is not 2n. We are adding the first n even natural numbers. So number of terms n only into. The first term is 2 and the last term is 2n. You can take 2 common. When I take 2 common, what happens? Here I will have 1 plus n. So into 2 and by 2 will get cancelled. It is what? N into n plus 1. N into n plus 1. Therefore, 2 plus 4 plus 6 and so on up to 2n, which can also be written in short form as sigma 2n, is equal to n into n plus 1. A basic example based on this. What is 2 plus 4 plus 6 and so on up to 100? My first question is, how many even numbers are added here? By taking the last term, we can find the number of even numbers. What is it? The last term is 2n, which is equal to 100. Therefore, n is equal to 50. I have added 50 even numbers. First 50 even numbers. So therefore, what is the sum here? The sigma 2n, the sum of first 50 even natural numbers. The formula is n into n plus 1. That means 50 into 50 plus 1. So multiply it and you will get the answer as 2550. The sum of these first 50 even natural numbers is 2550. The third result is sum of first n odd natural numbers. So 1 plus 3 plus 5 and so on up to nth odd number is equal to what? Let us find out what is the nth term here first of all. How to find the nth term? Actually, it is not needed. How many number of terms? N terms. N number of terms, right? So let me find the sum of first n odd natural numbers. The formula, this time I am going to use n by 2 into 2a plus n minus 1 into d. Why we are using this formula? Because we don't know what is the nth term. So the number of terms n as it is. 2a, here the first term is 1. 2a means 2 into 1 plus n minus 1 into the common difference. a2 minus a1 is 2. n by 2 into 2 plus 2 into n is 2n minus 2. So plus 2 minus 2 cancels. n by 2 into 2n into 2 by 2 get cancelled. You will get n square. Therefore, the sum of first n odd natural numbers is equal to n square. What is the conclusion? 1 plus 3 plus 5 and so on n terms is equal to n square. Here you might have a question. Sir, what is that nth term? Because in the previous two results we have seen what is the nth term. If you want to know what is the nth term, let us find nth term by using its formula a plus n minus 1 into d. So a is 1 plus n minus 1 into the common difference is 2. So if you expand 2 into n, 2n, then minus 2 plus 1 is minus 1. So therefore, dear students, if you want to write the nth term here, I will write it as what? 1 plus 3 plus 3, 1 plus 3 plus 5 and so on up to 2n minus 1. The nth term, please remember this, the nth term in odd numbers is not n, it is 2n minus 1, the nth term. Okay, the sum of first n odd natural numbers is equal to what? It is equal to n square. An example if you want. What is the sum of first 50 odd natural numbers? So 1 plus 3 plus 5 and so on. How many odd natural numbers? We are going to add 50 numbers, 50 terms. The sum of first 50 odd natural numbers is equal to 50 square, which is equal to 2500. 2500. The next important deduction, we generally use it in some of the problems. Nth term in terms of sum of n terms. So what is it? Sorry for the disturbance. Let us come back. Nth term in terms of sum of n terms. Okay. So an is equal to sn minus 1. The first reduction. And the second one is what? Common difference in terms of sum of n terms. Okay. So let us derive both the formulae. First of all, try to understand what is the meaning of S1. What is the meaning of S1? Sum of one term or sum of first term. So which means we are taking only A1. So please understand that A1, the first term is nothing but sum of one term. And what is S2? S2 means what? The sum of first two terms, which means A1 plus A2. And what happens when I do S2 minus S1? S2 minus S1. So S2 is A1 plus A2 minus A1. So these two will get cancelled. I will get A2. Therefore, what is S2 minus S1? I will get A2. Similarly, what is S3? S3 means A1 plus A2 plus A3. The sum of the first two terms. And please observe, A1 plus A2 is nothing but S2. And from this, we can find what is A3. So what is A3? A3 is equal to S3 minus S2. Now please observe, A1 means S1. Fine. I got that A2 is equal to S2 minus S1 and A3 is equal to S3 minus S2. Please observe, A2 means S2 minus S1. A3 means S3 minus its previous S2. So then what is A4? We can easily say A4 is what? S4 minus its previous S3. And A5 means what? S5 minus S4. And so on. Finally, we can conclude that an, the nth term is equal to what? Sn minus its previous Sn minus 1. Sn minus Sn minus 1. Remember it. The nth term is equal to Sn minus 1. Similarly, let us derive the common difference formula. We already know that the common difference is an minus 1. the nth term minus its previous term. And according to this, an can be written as Sn minus 1 minus of an minus 1 according to this formula. An minus 1 means Sn minus 1 minus its previous. What is it? An minus 1 means Sn minus 1 minus its previous is Sn minus 2 over Sn as it is minus Sn minus 1 minus Sn minus 1 is minus 2 times Sn minus 1, and minus into minus is plus Sn minus 2. So this is the common difference in terms of sum of n terms. But frankly to say, while we are solving the problems, instead of using this much big formula, we can simply find S1, S2, S3 and then A1, A2, A3, and then we can find the common difference. Okay, fine. So when the need arises, we will see how to find the common difference also in problems. Now we will continue with the next deduction. The sequence whose sum of n terms is of the form Sn is equal to, please observe this, Sn is equal to an square plus bn, where a comma b are some constants. They can be real numbers, they can be complex numbers also. If sum of n terms is in this form, then it is always in AP. Then the sequence is always in AP. In another language, if the sum of n terms is a quadratic expression without constant. See, n square term is there and n term is there, but constant is missing, right? If sum of n terms is a quadratic expression without constant, then the sequence formed because of this Sn is always AP. Okay, so let us derive it now. Let us derive that the sequence formed is always in an AP. So if you find an using the formula Sn minus Sn minus 1, so Sn is an square plus bn minus of, let me find out what is Sn minus 1 here separately. Sn minus 1. Sn minus 1 means a into n means, n will be the number of terms n minus 1 plus b into the number of terms n minus 1. And if I expand it, what do we get? A into, using a minus b whole square expansion. So n square minus 2n plus 1 plus b into n minus 1 is bn minus b, right? That is nothing but an square minus 2an plus a plus bn minus b. So let us substitute the same here. An square minus 2an plus a plus bn minus b. So clearly plus an square and minus an square will get cancelled. Plus bn and minus bn will get cancelled. An square minus an square plus bn minus bn. So what is remaining? Minus into minus, 2a into n, and then minus a plus b. In the previous video we have discussed that the nth term of an AP is always a linear expression, linear polynomial. Is it correct? Linear polynomial in terms of n? Yes. If nth term is a linear polynomial in terms of n, then the sequence formed will be in AP. So this clearly says that the given sequence is an AP. Why the given sequence is in AP? Because the nth term is a linear polynomial in terms of n, whose common difference d is the coefficient of n. What is the coefficient of n here? 2a. So we got a direct formula, dear students. Please observe. If you know sum of n terms, by looking at this quadratic polynomial, directly we can write what is the common difference. So what is the common difference? 2 times n square coefficient. Correct? N square coefficient, if it is a, then the common difference is 2a. Okay, fine. So we'll look at an example. What is it? Find the nth term, the common difference, and the AP itself, whose sum of n terms is given by minus 2n square plus 3n. So we have already discussed in the previous deduction that if sum of n terms is a quadratic polynomial without constant, then certainly the sequence that forms is in AP. Now let us see it. What is the method? Let me find S1. S1 is equal to what? In place of n, I will take 1. Correct? So minus 2 into 1 square plus 3 into 1. So you will get minus 2 plus 3, which is equal to 1. Next S2. S2 is what? In place of n, I will take 2. So minus 2 into 2 square plus 3 into 2. And what do we get here? Minus 8 plus 6. Minus 8 plus 6, which is equal to minus 2. And S3. S3 is equal to minus 2 into 3 square plus 3 into 3. So 3 square 9, 9 2s are 18. So minus 18 plus 9. And we get minus 9. I got S1, S2 and S3. Now I can find A1. A1 is equal to S1 as we have discussed it before, which is equal to 1. A2 is equal to S2 minus S1. S2 minus S1 means S2 minus 2 minus S1 1, which is equal to minus 3. And A3 is equal to S3 minus S2. So S3 is minus 9 minus of S2 is minus 2 and we get minus 7. Therefore, what is the AP, dear students? AP is given by 1 comma minus 3 comma minus 7 comma and so on. And if you know AP, you can find what is common difference. So what is common difference? A2 minus A1. So second term minus first term. So how much do we get? Second term is minus 3 minus first term is 1 and we get minus 4. The common difference is equal to minus 4. And finally, what is nth term? We should also find nth term, right? Using AN formula. AN is equal to A plus n minus 1 into D. Now, A is 1 plus number of terms n itself. Please understand this. If you are finding nth term, the number of terms n itself into common difference is minus 4. Since common difference is negative, I'll keep a bracket. Please observe this. So now if I expand this 1 as it is, minus 4 into n minus 4n. Minus 4 into minus 1 plus 4. And finally, what do we get? 1 plus 4 is 5. 5 minus 4n. That is the nth term. The nth term is given by 5 minus 4n. So dear students, as I told you before, in the previous deduction, I gave you a direct formula to find the common difference. What is a direct formula? D is equal to 2a, right? Where a is the coefficient of n square. I can use this direct formula to find common difference because in some problems we just need common difference. In those cases, I can directly use this formula. What is it? Here a is the coefficient of n square, which is minus 2. 2 times a is minus 2. Please do not misunderstand this a with first term. No, do not misunderstand it. Okay. So d is equal to minus 4. Is it correct? If I use this formula, I'll get the common difference directly. In this case, a means the coefficient of n square. Do not misunderstand this a with first term. Okay. So this is our second problem. Here is our third question. A third question to get a clarity about sum of n terms. By looking at the sum of n terms, we can directly say that the sequence formed is certainly not in AP. What is the reason? Because this sum of n terms is a quadratic polynomial along with constant. See, if constant is there, the sum of n terms, this sum of n terms will not give us AP. It will be some other sequence. Okay, now if constant is missing, then we can say that sum of n terms will give, this sum of n terms will give you AP, but we have constant, right? Let us study. Let us find out what is the sequence first. Okay, so first I will find S1. S1 is equal to what? 4 into 1 square minus 2 into 1 plus 3 and we get 5. S2 is equal to 4 into 2 square minus 2 into 2 plus 3 and what do we get here? 16 minus 4, 12, 12 plus 3, 15. S3 is equal to 4 into 3 square minus 2 into 3 plus 3. So we will get 9 4s are 36. 36 minus 6 is 30 plus 3 is 33. And one more. Let us find one more. Is 4 also. 4 into 4 square minus 2 into 4 plus 3. So what do we get here? 16 4s are 64. 64 minus 8 is 56. 56 plus 3 is 59. Now let us find what is A1, A2, A3 and A4. Okay. So A1 is directly S1, which is equal to 5. A2 is equal to S2 minus S1. S2 minus S1 is 15 minus 5, which is equal to 10. A3 is equal to S3 minus S2, right? S3 minus S2, which is equal to 33 minus 15, 18. And A4 is equal to S4 minus S3. What do you get? 26. S4 minus S3, which is equal to 26. So therefore, what is the sequence that's formed here? The sequence is 5, 10, 18, 26 and so on. Please observe one thing. A2 minus A1 is 5. Correct? A2 minus A1 is 5. And A3 minus A2 is 8. Of course, it is not in AP from the first term. But if you observe one thing, what is A4 minus A3? You will get 8 here. If you try to find what is A5, A5 will be 34. Please, if you do it, you can try it once. Try to find the fifth term, you will get 34. What is A5 minus A4? A5 minus A4 is also 8. Please observe one thing, dear students. The sequence from the starting is not in AP. But if I ignore the first term, the sequence will be in AP. So what does it means? What is the conclusion? The conclusion is that if sum of n terms is of the form an square plus bn plus c, then the sequence will be in arithmetic progression from the second term. That means what? If Sn is of this form where a, b, c are constants, then A2, A3, A4 and so on will be in AP. The sequence will be in AP from the second term, not from the first term. So keep this in mind. Okay, na? So these are the subtopics for today's class. In next class, we will cover more properties and more deductions on sum of n terms. And we will go into solving many other problems. We will see the solutions for many other problems, important models and all. Okay, so thank you for being patient while listening the class. Certainly it will be helpful for you. So if you have understood the concept, do like the video and share this video with your friends. And if you have not yet subscribed, please subscribe my channel, The Concepts of IIT Maths. This is M. Sandeep Kumar, and we will meet you in the next video.